All right, ladies and gentlemen, I hope you guys enjoyed your test. I'll be grading those as soon as I get a chance because right now my internet is down at my house. I'm being forced to do some things from the school, which is not good. But in the meantime, let's look at section 5.1. Section 5.1 deals with quadratic functions, so these are your basic parabolas. Let's start by talking about some pretty important characteristics to remember. And before we begin, don't forget, we have our homework assignment, page 357/375, so number in the text versus in the PDF. And then 1 through 45 odds, and number 72 and number 73 are being added to the end. All right, let's take a look. Remember, parabolas are your basic U-shapes. In your basic U-shapes, there are a couple of important features. Some are old features, some are new ones, so let's talk about those. Old features include things like x-intercepts. Remember, those are places where we cross the x-axis. With a parabola, it's possible to have 1, 2, or none. It depends on the location. Y-intercepts, it will always have 1. But what makes things specific to a parabola is it'll have something called an axis of symmetry, which is a place where the middle of the U is, and a vertex. And the vertex has some big properties we're going to be talking about. So let's start listing out some definitions. Let's see. Parabola. This is the name we give for the basic shape of a quadratic equation. So it's that nice little U shape. And there's two different varieties depending on the values in question. Let's see. Axis of symmetry. If you remember from geometry, the word symmetry refers to the reflection. And so your axis of symmetry is the median line through the parabola. So in this case, for my picture, my axis of symmetry would be in red, right there, and right there. So it's the middle line in between these parabolas. Calm down. All right, finally, we have the vertex. The vertex is by definition, vertex, V-E-R-T-E-X. Someday I'll learn how to spell. The vertex is the minimum or maximum value of the parabola. So in this case, here in purple, this particular version of a parabola would have a maximum, whereas this one would have a minimum. But in this case, they're all vertexes. So we got a max and a min, but they're both vertexes. Notice that anytime you have a parabola, because these things are going on forever, they're going to have some little properties. They're going to help us to determine other variations on what makes it a parabola and the vertex and the max and the min. When it comes to things like real-world problems, things like the vertex are incredibly important because they're usually the most important value in the parabola. And otherwise, the axis of symmetry is less important, but it really helps if you're planning on drawing it. So if you're graphing, axis of symmetry is very helpful. And between these two things, they're going to lead right into our first couple equations. So we have something referred to as G general equation and the standard equation. When we talked about lines, one of the things we talked about how there's multiple forms of the line. You have something called point-slope form, but you also have something called slope-intercept form, and then you even have something called standard form. Well, in this case, for the general equation, there's pretty much just two that everybody cares about the most, and these two are listed right here. So, the general equation, y equals ax squared plus bx plus c. This is the general equation. Notice this is written like a polynomial, like any other term. This is very similar to what you see in a linear function as your standard form in linear. But in a quadratic, standard form contains one other piece. So y equals a x minus h squared plus k. where in this case, H and K are the vertex. And so if you care about the vertex, you probably want to be looking at things in standard form. If you don't care about the vertex, you probably want to look at a more general form. Both are useful. Of the two, this is the better in almost all cases. That is why it's referred to as standard, is because it's the better one in almost all cases. The standard form of this equation, because it's easier to go from here to there than the other way around. Almost always. Now, there is a couple things to help us with this. And one of the first questions that you're going to be asked today is questions about how do you find the vertex. So, how do we determine what the vertex is? Now, if it is in general form, the process is a little bit more difficult. If it's in standard form, the process is a whole lot easier. So let's talk about general form. If it's in general form, your h is defined by the equation negative b over 2a. And so it's a simple plug and chug. Notice we use from the general form our two components, the a, which is the coefficient of the x squared term, and the b, which is the coefficient of the x term, the linear term. Notice we do not use c at all, because it's not important in terms of finding the vertex. Now, when it comes to k, the second part of the vertex, because each vertex contains two values, the x value, which we've listed as h, and the y value, which we've listed as k. To find k, all you have to do is plug in h. So everywhere there used to be an x, you replace it with whatever number we get from h. And so let's talk about our first equation today. And for this one, let's look at an example we have earlier. We should be looking at two of them. I don't like any of those. You know what? Time to make one up. Okay. So for this problem, let's look at our first example. And we're going to find the vertex. For the first part, let's look at the equation y equals 3x squared minus 9x plus 5. We're going to use this to attempt to find the vertex. Now, in order to find the vertex, I'm going to use this form. H equals negative b over 2a. I'm going to plug into that form and find h. So that's my first goal. I find h. So step 1, I plug in negative b. So there would be negative 9 over 2 times our a value, which is 3. Notice how the formula is written. It's possible to end up with some double negatives, so be sure to differentiate between the negative in the equation and the negative in the problem. We have to keep this minus sign with the 9. That's why it's negative 9. Here, negative times a negative would make it positive, making this a 9 on top. On bottom, we end up with 2 times 3, which is 6. And it's to simplify into 3 over 2. So this tells me my h value. So the first part of my answer is the vertex is at the point 3/2, or if you prefer, 1.5. And then I need to find the other part of this, which is the k value. To find the k value, all I got to do is plug this number that we found from h into the equation. That's what I'm going to do. Everywhere there used to be an x, I plug in h. This is probably the most annoying part of these problems, is usually h is pretty nice. Sometimes k can get kind of nasty. And so you want to make sure to always double check your stuff, make sure all your components are where they're supposed to be, and keep up on those algebra skills. Okay, so 3/2 squared becomes 9/4 times 3. Okay, 9 times 3/2, so 9 times 3 is 27 over 2, and then plus 5. 3 times 9/4 would be 27/4 minus 27/2 plus, I'm going to go ahead and convert this. Let's see. I see my largest number is a 4, so I'm going to take this and turn it into 20 over 4. All right, looking pretty good. This middle one will become 54 over 4. Multiplying the top and bottom by 2 so that they all match. And then I combine them. We have a positive 27 minus 54 that become negative 27 plus 20, so that's negative 7 over 4. So now that I've got my h, now that I've got my k, I just write them down. And there's my vertex. If the problem asks you how to find your vertex, it's these two steps. The first step is usually the easier one, where you just have to plug into negative b over 2a, which we did. The second one's a little harder because there's going to be some simplification. If you have a calculator, this can be really helpful to use. Just make sure this piece needs to be in parentheses, especially if it's got a negative sign, because that square is going to be wonky if you don't do it correctly. From there, the rest is just simplifying until we get both answers. Notice the order. H goes first, K goes second, and there's our vertex. Let's do another example. So that's our first example using this type. Let's take a look at it. Again, we were given an equation. We plugged in and found H first. Then once we found H, we wrote that down. We then plugged in and found K. Once you've got both answers, we have our vertex. Okay, let's look at our second example. Okay, let's use a little bit nicer equation. Y equals x squared plus 4x plus 7. Okay, let's do it. So if we are again asked to find the vertex, all we need to do is find first h. So h equals negative the b term, so it'll be negative 4 over 2 times our a term. If it's just x squared, that means there is 1x squared. From there we simplify. Negative 4 is just negative 4. 2 times 1 is 2. Negative 4 over 2 is negative 2. So here's my h term. Negative 2, comma. I need to now find my k term. So let's do that. I find k. K equals. Everywhere there used to be an x, I'm going to plug in negative 2. So we have negative 2 squared plus 4 times negative 2 plus 7. I'm going to do it by hand. Negative 2 squared is 4. 2 times 2 is 4. Negative times a negative makes it positive. 4 times negative 2 is negative 8 plus 7. Negative 4 minus 8, 4 minus 8 is negative 4 plus 7 would be positive 3. And so my vertex is the point negative 2, comma, 3. Again, notice the process. We find h first, then we find k afterwards. As a last example, this is the far easier one. What do we do if it's written already in standard form? It was already in standard form, just copy down h and k. Just make sure you copy down the correct h and k. If it's already in standard form, you just need to plug in h and k and write your solution. So this is where a good example in the textbook is. Let's go to right here. This equation is y equals negative 3 x plus 2 squared plus 4. So we're going to take this equation and find the vertex. To find the vertex, remember, in standard equation, the h is the term that's with the x, but it's negative h. What this tells me is whatever sign is inside of this function, I need to switch it. So if I have minus 2, my h is just the 2. If I have plus 4, my h is negative 4. Compare that to the k. The k, you'll notice, is plus k, which tells me that in the end, the answer will be the same answer. So if this is plus 3, it would be 3. If it is minus 6, it'd be negative 6. Let's take a look. In this problem, we have our function that tells me that for this problem, this term is my negative h. This term is my k. To write out in the form of a point, I need to have the positive version of h, so I switch the sign. Positive 2 becomes negative 2. And then the 4 stays a 4. Much easier and faster to do it this way compared to what we call general form. General form is a lot more difficult. Standard form is a lot easier. That's why we like it. Okay. So there's your first piece of your homework, is to find vertexes. So to find the vertex in the problem, note there are 2 different ways depending on which form it's in. If it's in general form, we need to use the formulas, define h and define k. If it's in standard form, much easier process, just read h and k. Just make sure to double check. It should be, it should be in this form whenever you're finished. And so if it's, you have to switch the sign on the h, so positive 2 becomes negative 2, and keep the sign on the k, so positive 4 stays positive 4. All right, next part. Axis of symmetry. The axis of symmetry for all of these functions will always be a very, very simple equation. Now, it is an equation. The equation is x equals h. So, in these 3 examples, let's take a look at what it looks like when you have this equation. So, if we look back at A, my point was 3/2, comma, negative 7/4. So my axis of symmetry would be x equals 3/2. It's just the h term written as x equals. And notice this is not like algebra, the variable x equals 3/2. This is the equation x equals 3/2, which from last chapter means this is a line going up and down through 3/2. For b, similar process. For my b equation, I had the point negative 2, comma 3 as my solution. So how do I write that as the equation? Well, I would do x equals negative 2. Notice that my c and my b have the same axis of symmetry, yet are different equations. They're very different. They have different vertexes for one. See how one has a vertex of positive 3 for its y value, the other one has a vertex of positive 4? Well, that's because they have different equations. Yes, they have the same axis of symmetry, but not everything's the same about them. So, these are the first few problems you're going to see tonight. Problems involving things like the vertex and the axis of symmetry. Okay. Included in this, let's talk about min and max. So, last piece. If a question ever asks you to find the min or max, if it ever asks to find the min or max, what it really means is find the vertex. How many explanation points do I need? All right. If it says find the min or the max, it really means just find the vertex. Now, there is a trick to this. There are 2 parts to it. Does it want to know what the x value of the vertex is? Does it want to know what the y value of the vertex is? And usually there's context to help with this. You cannot go wrong by just putting the point hk. You cannot go wrong with that system. But if it ever asks you to find the min or the max, it's really saying just find the vertex, which you can do by either of these 2 versions. If for some reason your equation is not in one of these 2 forms, like let's say your c is on the other side, well, algebraically you can just move it around. You're always allowed to make adjustments to these equations before you begin. Same with the k. If the k is in the wrong spot, just move it around. This is one of the advantages of having these general forms of the equation and the standard form of the equation, is if it's not in that form, get it into that form. Okay, next. Included with the conversation about min and max, you can predict the min or the max using some properties of the equation. If your a value is bigger than 0, you're going to have a minimum. If your a value is smaller than 0, you're going to have a maximum. This is because if the a is bigger than 0, it means that for the graph, your parabola is opening upwards. And because it is opening upwards, it will have a minimum value. If the a value is less than 0, that indicates it is opening downwards. And if it's opening downwards, that means it will have a maximum value. So, you can always predict whether it will be a min or a max by just looking at the a value. And notice that in both equations, pulling that back, both equations have a in them. And so no matter which form it's in, you can always determine whether it has a min or a max and which one it has just by looking at the equation. All right. Along with min and max, let's talk domain and range. It's been a little while, so let's refresh ourselves. The word domain means the allowed x values. Or if you prefer, the allowed inputs. What are you allowed to plug in? And the range is possible y values or possible outputs. Now, the domain for these functions, there's two versions. In general, the domain is negative infinity to infinity, meaning you can plug in anything you want, and it works. However, in some real problems, like if they give you a realistic situation, you have to look at the context. There's a chance in the real problem that there's a number that doesn't make any sense. For example, if the function is talking about a quadratic equation dealing with, let's say like a basketball or a rocket, which is really common in real world problems. Well, some of the situations don't make sense in the context of the problem. Like if it's talking about time usually needs to be bigger than 0. And so if you need to double check if it's a realistic problem, there's a possibility that domain is going to be a little weird. But I'm sleepy today. In general, negative infinity to infinity is the standard. For the range, it depends on the situation. If you have a minimum, so remember, if you have a minimum, that means your a value is bigger than 0. Then the range will be from k to infinity. If you have a maximum, then will be from negative infinity to k. This should make a lot of sense. From k, remember, it's supposed to be the y value of the vertex. So if I'm looking at an example, let's use a nice big example here. Pull in all of our terminology. Do one example here in, stupid cord. Okay, one example here in blue. Now, if I have a parabola, like so, it has a vertex. In this case, this is negative 3, 2. Okay. Well, its domain would obviously be all round numbers. So from negative infinity to infinity. Because you'll notice that from this particular version, you have every x will have a y. Meaning if I go over here, it will eventually have a y value, maybe way up here, but it's there. So every x has a y. But notice that there's no y's down here. The y's are missing. There's a gap. If I try to ask, what x value will get me all the way down here, there isn't one. Because if I go over here, like this is the closest I'll get to that line. It never actually crosses this y value. And so that's not included. So if we ask about the range, notice that it has a minimum. Because it has a minimum, the answer is from the k value, which is -2, to positive infinity. If we compare this instead to a different graph, where it has a maximum, let's say this graph, which has a vertex, right about there, which is the point 1, 2, 3, 4, 5. So its domain would again be all of our numbers from -infinity to infinity, but its range is different. It has a maximum, therefore its range is from -infinity to 5, the k value of this function. This represents to our problem that we have different domains and different ranges depending on the context. Notice that because both these are general, the domain stays consistent, -infinity to infinity, -infinity to infinity, -infinity to infinity. But the range changes depending on context. Is there a minimum or is there a maximum? Which, remember, we can determine by looking at the a value. Or you can just look at the picture. If there's a minimum, well then you can do the minimum steps. If there's a maximum, then you do the maximum steps. So there we have it. This is the majority of your homework tonight. But this is actually the easier part of your homework tonight. Now I want to get some time to show a couple of examples of the harder part of your homework, which is how to find the equation and how to graph the equation. Now, most problems tonight have you doing this in 2 steps. So finding the equation. There's 2 different versions of this. The first version is going to be given the vertex in a point. The second version is going to be given a graph and a point. Well, I guess with the graph it's more vague. But let's take a look. I'm going to go to my book, showcase some examples, and scrolling. Oh, good thing to remember is that you can always switch from the standard form to general form just by foiling, and that'll eventually get you to standard form, but it's much harder to go backwards. Okay, good, did that, we did that, cool, domain and range, we did that one. How to find it, there we go. Okay, determine the min-max values, that just means to find the vertex. And so that was easy. These ones are great for 72 and 73. Example 6, looking at this one will really help out with example 72 and 73 in your homework. Okay. Looking good. I think I'm going to have to use a homework problem, which is exactly what I'm going to do. Okay, so let's look at one like number 26. We need number 26 together and kind of showcase how do we use the vertex and a point to determine the general form of the equation. Okay, let's do it. We got h and we got k, so let's take a look at the problem. For h, we have 2. For k, we have 0. This is my h comma k. And for my point, my x and my y are 4 and 4. Okay. The problem specifically states they want it in general form. Which, remember, if we look back, general form was this top one, ax squared plus bx plus c. Now, in order to put it in general form, I always believe it is better to put it in standard form first, and then work backwards to put it in general form, rather than trying to go immediately to general form. In most cases, general form is just harder to do, and I am really not a fan. I'd rather do standard form, because if the problem says just find an equation, then when you got standard form, you're done. But in these problems, it says to find specifically the general equation, So we have to be able to do it in both forms. So if I want to do one, I'm going to do both. So to do this, I'm going to use my first equation, which is y equals ax minus h squared plus k. So how do I do that? Well, everywhere I can plug in, I am going to plug in. I know what h is. H is 2. I know what k is. K is 0. So let's try this out. Y equals, I don't know what a is, so I'll leave a there. It's tempting to plug in x and y, but this is actually going to come in later. So I'm going to go ahead and leave that as separate. X minus, my h value is 2 squared, plus my k value, which is 0. This is pretty good. We're already most of the way to an equation. We just don't have one thing missing, a. So step 1, plug into vertex form. Okay, step 2, once we've plugged into vertex form, we're now going to plug in x and y and solve for a. So I noticed that I'm saving it right here. I want to go ahead and write this piece down because I'm going to come back to it. I could immediately plug in x and y and keep going, but I'd rather save that step because I want this equation for later. If I do both right now, I'll have to come back and get it later. I'd rather just do it now. So everywhere there's a y, I plug in 4. Everywhere there's an x, I plug in 4. Notice that I'm left with one equation that has just a in it. So I plugged in h, I plugged in k, wrote it down. Plugged in x, plugged in y, wrote it down. And now the next piece says solve for a, meaning it gets a by itself. So this becomes 4. 4 minus 2, I can do that. 4 minus 2 is 2, and it's squared. And then plus 0 doesn't really do anything. So I'm just going to leave it as going away. 2 squared is 4, so this becomes 4 equals a times 4. I want to get a by itself, so divide by 4. If I divide both sides by 4, anything divided by itself is 1. Let's see what a is. So now that I've gotten that piece done, and I found a, what I'm going to do is I'm going to plug a into vertex form. This is why I go ahead and write that piece down, is because if I have the problem already written out, now I can just go ahead and plug it in here. And so I take this equation, and I write it down. Y equals 1 times x minus 2 squared plus 0. If the question asked for vertex form, then we would be done. If the question just said find the equation, we'd be done. The question says to find the general, and so I need to take an extra step here to go ahead and rewrite this to be in the other form. Now to do that, I'm going to use some properties of algebra. To rewrite this. Now, first property I'm going to use, x minus 2 squared just means x minus 2 times x minus 2. And the plus 0 is just a plus 0. Okay, 1 times this isn't going to do anything, so I can drop the 1. The plus 0 isn't going to do anything, so I can drop the 0, leaving it in this form. And then I can use FOIL to rewrite it. So y equals x squared. Let's see. So x times x is x squared. X times negative 2 would be negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. So I end up with y equals x squared minus 4x plus 4. This is now in general form. Verify. It's in general form. Ax squared plus bx plus c. Ax squared plus bx plus c. It's in general form. And I'm done. So, If the problem says to find the general form of the equation, this is how we do it. We start by plugging into vertex form and write that solution down. Once you plug into vertex form, we now plug in x and y from the point. So that was 4 and 4. And then we solve for a. We then plug a back into the equation, giving us vertex form. And then we rewrite it in terms of general form. Before I look at the graphing version, I want to do one more of these. One that's a little tougher. So, let's plot another piece. Alright. Let's look at 30. So, number 30 states, we have our HK, which is negative 5, comma 3. And we have our XY, which is 2, 9. Once we have these two, let's go ahead and talk about our function. So, step 1 was, we plugged into vertex form. Y equals A, parentheses, X. Okay, so minus comes from the equation, but there's already a minus in the problem. Plus K. And if I want to go ahead and rewrite, that's Y equals A x plus 5 squared plus 3. So that's step 1. Step 2. Once you've got our equation, we now want to plug in x and y and solve for a. So I plug in our y value is 9. Our x value is 2. And then we start solving. 9 is just a 9. 2 plus 5 is 7, so this becomes a times 7 squared plus 3. Order of operations says we do the power first, so 9 equals a times 49 plus 3. I can combine the a and 49 into 49a, but I cannot add 3 to that because addition and multiplication do not combine, so I'm going to subtract 3 instead, leaving with 6 equals 49a. And then I divide both sides by 49. So we get 6 over 49 equals a. Step 3, once we got that piece, the a, we then plug it back into this form. So we do y equals 6 over 49 times x plus 5 squared plus 3. Okay, this is now written in vertex form. If the problem says write it in vertex form, we are finished. If the problem says write it in standard form, we now need to keep going. So step 4. I'm going to rewrite y equals 6 over 49 times x plus 5 times x plus 5 plus 3. Now I can go ahead and FOIL out this middle piece here. So y equals 6 over 49. I'm going to leave there for just a moment. Now when I FOIL this out, I take x times x, I get x squared. X times 5, giving me 5x. 5 times x, giving me another 5x. And 5 times 5, giving me 25. I can now distribute the 6 over 49. When I distribute the 6 over 49, I get y equals 6 over 49x squared. These two make 10. And so 10 times 6 over 49 would become 60 over 49. X. Ooh, fun one. 25 times 6 over 49. So 25 times 6. 25 times 6 is 150 over 49 plus 3. The 3 doesn't get multiplied because it's outside the parentheses. And then last step, I want to combine like terms. So 6 over 49 x squared plus 60 over 49 x. 3 times 49 would be 147, so plus 150 over 49 plus 147 over 49, which gives me the final very weird equation, y equals 6 over 49 x squared plus 60 over 49, apologies, x plus 297 over 49. Wow, that was weird. But that's the general equation. Notice why we like vertex form so much. It's so much easier to get into. You don't have to go through all these extra steps to get to the general form. But the problem does say to get it in general form, so I make sure to do that. Now, what's the nice thing? Well, if it says do it from a graph, the nice thing is, all you have to do is find the vertex, find a point, and then same steps. So for example, if I look at this graph, which says, ooh, these are the nicer ones, like 40, 42, and 44. These are nicer because they've noticed it just says find the equation or write the equation. It doesn't specify general form, so I can actually stop here if I want to, which is super convenient. Okay, so let's look at 40 as our example. So step one, I want to find the vertex. If I look at my graph, the vertex is right here. It's the minimum in this case. It is a vertex at positive 2 and negative 3. So this tells me this is my h, this is my k, and I can start plugging in just like I plugged in h and k over here. I need to also find another point. Now this point can be any point, so I suggest making it one that you're absolutely certain is in the graph. For me, there's a couple to choose from. I like this one, which is at 4, 1. But there are many other options for the second point. Like I could have chosen 3, negative 2. I could have chosen 1, negative 2 and used this point instead. I could have chosen 0, 1. Ooh, 0, 1 would have been really good. But, you know, you just got to choose a second point and then go. And so now that I'm here, I can essentially follow the exact same steps. It's just they didn't give me the points this time, which is really fun and convenient. Okay. So that's the next major part. There is one final piece, which you might notice if you look at 34 through 39. You can kind of tell what it's going to be. How do we graph these? How do we graph an equation? How do we graph a quadratic in this case? Well, I recommend the following steps. Step 1, find the vertex. That means find h, find k, and find that point. Step 2, once you've got the vertex, I recommend table the vertex. What that means is put your h value in the center of a table. Pick 2 numbers to the left and 2 numbers to the right of that number. And then find the other parts of your table. So if this is x's and y's, so you want to pick numbers to the left of h and numbers to the right of h that then allow you to plug in. Alternatively, just plug in one side and use the axis. We've done this once before a little while ago, so let's talk about number 34. How do I graph number 34? The equation is x squared minus 2x. How do we graph this thing? Well, let's graph it by first step, find the vertex. The vertex, I want to find h first. To find h is negative b over 2a, which means up to negative b, so in this case I would have a double negative from negative and negative 2 over 2a, so that would be 2 times 1, because there's a single x squared. Double negative makes this positive, so that becomes a 2 on bottom 2, and 2 divided by 2 is 1. That tells me my h value is 1. My k value just means I got to plug in 1 everywhere. That means I take x squared minus 2x. Everywhere there used to be an x, I replace with 1. So 1 squared minus 2 times 1. And we start simplifying. 1 squared is 1. 2 times 1 is 2. 1 minus 2 is negative 1, which tells me I get this as my vertex. So, step 1. Find the vertex. It's the point positive 1. Oops, I'm on the page. It's at the point positive 1, negative 1. So there's my vertex. Now, to find the next points, I'm going to make a table. My h is going to be at the center of this table. I need to pick values to the left of h and values to the right of h. This is my h value. So in this case, to the left of 1 would be like 0 and negative 1. To the right of 1 would be like 2 and 3. I can choose any numbers, but near numbers are better if you can use them. So I already know the y value for 1 is negative 1, but now I need to find these other values. So I need to plug in 0 and 2, I need to plug in negative 1 and 3, and then I'll just plot those points. If you do this correctly, you might notice something about the axis up here that we were talking about. So let's plug in 0. If I plug in 0, 0 squared minus 2 times 0, all of that means 0. If I plug in negative 1, negative 1 squared is positive 1. Negative 2 times negative 1 would be positive 2. 1 plus 2 is 3. If I plug in 2, 2 squared is 4, minus 2 times 2 is 4. 4 minus 4 is 0. And if I plug in 3, 3 squared is 9, minus 2 times 3 is 6. 9 minus 6 is 3. So we go 3 and then 3. A couple things to note here. 1. You notice these points make this nice U shape. Number 2, I can predict that because if I look at my A value is 1. 1 is bigger than 0, as we talked about before. If you want to know whether something's going to be a maximum or a minimum, it matters whether the A is positive or negative. Since A is positive, we know it should open upwards, which means this should be a minimum. And notice where the symmetry comes from is the symmetry here. Negative 1 is the center. Notice to the left and to the right are the same. So yes, our x's are 0 and 2, but our y is the same, 0 and 0, 3 and 3. If we continue this trend, the next number out would be 8. So it'd be negative 2, 8, and 4, 8. They would be the same y values just by having different x values because that's what symmetry does, is it makes it look the same. That's all we got today. Just as a reminder, your homework assignment is page 357/375, 1 through 45 odds. Include in there number 72 and number 73. If for some reason I have not gotten the test graded by Wednesday, it is probably because my internet is going crazy. I will try to get those graded as soon as possible, and I will be allowing test corrections. Once I get the test graded, I'll try to figure out how I want to do that and let you guys know. Until then, I look forward to seeing you guys. Let me know if you have any questions, and I'll try to answer as many of those as I can on Friday. Have a good rest of the day.